Everyone, welcome back to making a Pokemon save editor in C. Where are we at now? Part 9? Part 9. How cool is that? So I'm carrying on with the text encoding that we were doing not too long ago. So last time we kind of found some characters that we actually don't want to use. So I've since removed those and I've just kind of added a to-do here which says find a way of actually being able to deal with these special characters. I did have another idea on how we could potentially... I was basically trying to use memset and I was clearly doing something wrong because we were getting lots of seg faults. I did have an idea which was to actually initialize the return value purely with FFs, and then we just write the encoded character to the position in our return string. But I'm not sure if that is... I think I tried this last night and it didn't work. So yeah, basically a variable size object may not be initialized. So I don't even think we need to initialize it. Maybe we can just do memset first. So let's see what we have. So memset writes len bytes of value C converted to an unsigned card to the string B. So we could literally just do something like of our output length. So we just write that with FFs and then we put all this back. So does this work? Yeah. Now it does say my encoded character blank was converted to nothing. So is that my default? It is. So it has actually written the space there. So I wonder if blanks do just kind of need to be FF. Let's start with FF. My encoded characters are this as well. Let's see if we can print like a character string as hex. So we can do HH to say it's an unsigned character. I actually don't know if trying to do it like a string would work. I guess not if it's unsigned. Maybe let's try this. My encoded characters are 196. Well, that still isn't necessarily what I'm looking for. I mean, it doesn't really matter if we can't print it because we actually know that everything in the string is okay anyway. Let's see. We sometimes need to print the string or character array with binary content in hexadecimal format. Then we can use the following C function. Okay, we actually have to print every single character for the length of the string. Dang, okay. So in that case, I guess we can do this. Oh, can we use strlen? Find length of string. Okay. So, oh, actually, do we terminate this string with a null? Because we've been setting everything to FF. So I don't know if string length is gonna actually work. But let's give it a go. Okay, well that doesn't actually seem right. DO71776F? What? Oh, don't know what I did there. Okay, well this is completely not what I was expecting. D0B1756B. I mean, it has kind of found those at least, but it's not. Two, three, four, five, six, seven, eight. Okay, yeah, this is still wrong, but at least that prints the correct size now. E0F1 1B6B. Well, that's clearly not. I don't know. What is the HH format specifier? Oh, with HH it becomes unsigned car or car. HHX means the corresponding arguments point to an unsigned car. Okay. But this is not right. So the actual encoding per byte is working properly. So does this get... interesting. It might be this warning we also had here as well about it escaping the function. Whoops. Also, what is the shortcut key for running? Command R. It's user's ID shortcut. Okay, so it does do the assignment properly. But this is not right. The address of the local variable may escape the function. Let's see what the internet says about that. Returning the address of a local variable from a function can lead to issues because the okay. The variable is destroyed once the function exits. Very interesting. Let me just turn that down real quick. Oh yeah, so I guess we have a pointer to something that only exists in this scope. So either we assign it on the heap, or we have a buffer that we pass in that gets actioned. I mean, I feel like, okay, this is interesting. I feel like this function shouldn't necessarily do the malloc, because you then need to be absolutely... You then need to free it outside of this function. So maybe if we had an input string and then we had so let's make it not return anything, and it will just mutate the unsigned character here. Then I guess we can call this ilen. So let's say encode the input string is of length ilen using the proprietary encoding. This function will return a so storing the result in OS. Where olen is the length of the output string. If ilen is greater than olen, null is returned. I still think we need to terminate the string as well. We also want to say any unfilled spaces between or let's say any unfilled characters in OS are replaced with 0xff. And if ilen is greater than olen, we return null. Okay. Maybe that's better. So it does mean that we kind of need to rewrite this function here a bit. So we want to not create a new return object. We want to fill olen with ff. Then that needs to be ilen, and the character that we're reading is is. So wait, we just access it like that. And then at the bottom of our function, input character converted to that, and then os at I becomes our encoded character, and then we want to print osi, and we have no return. So then in our program, we want to say we have an unsigned character encoded, which I guess is going to be actually 10. And then we want to actually call text encode. So the signature of text encode again is our input string, which is name. Then we have our output string, which is encoded. Can we actually do size of here? Yeah, okay. And then we don't need to do that. Or actually we can say... I mean, we probably should do some error handling here, but let's leave that for the moment. What is this music? It's far too crazy for concentration. There we go. Something like this. Anyway. Oh, hang on. C4, E3, E7, DC, FFFFFF. Yes. Okay. All right. So that worked. Although we do need 1, 2, 3, 4, 5, 6, 7, 8. Okay, we're doing size of name. So let's print that for size of encoded. Yeah, there we go. Okay. So then, if we were to apply this to our save file, so the player name is the first section of the trainer info. And it is a maximum of 7 characters. My encoded characters are that. I've entered that name. Return 0. Okay. So, if we were to do this logic, and then let's move this up so that we can do this a bit better. Alright, so we have our gender change. Which I suppose we can do, because we know that that works. Then we also want to set player name to encoded, which needs to also be 7 characters long. Or 8, rather. I think it needs to be 8. Because we need some kind of Terminator character here. I can't even remember where we were as well. Was it 11,000 in the save file? Yeah, so this is our name. So our player name becomes encoded, or we cannot assign to an array type unsigned character 8. Is it another mem copy? Copy m bytes from memory area source to memory area dest. Yeah, okay. So that's our destination. We are copying encoded, and it is the size of encoded. Sure. That needs to be an arrow and not a dot, yeah? Yes. Okay. So really, this should work. It's famous last words, I know. So we need a line break there, but it's calculated a new checksum for us that looks wrong because it's 2 bytes. Yeah, something something tells me that is broken. So we still have our copy too. Let me actually just like do this in the terminal. It'd be so much easier. Okay. I guarantee we will have a corrupted save. Oh, wait. What? It did work? But that calculated checksum looks wrong. Okay. I wasn't expecting that. Huh. Wow. Okay. Huh. Okay. Alright. Well, that is pretty cool. Yeah, okay. So, I guess I do kind of want to understand why is this checksum suddenly like more bytes than I would have expected. And that I don't know. This needs to be that. So CFB7 plus 45C0 makes that number, which I don't doubt, but well, maybe it is fine. But then I thought a checksum was 2 bytes. I mean, it could be 4. How do we check? Checksum. Oh, it is 2. Huh. I mean, I would be interested to see what it actually wrote to our file. So it wrote our name, which we know is correct, and it's got the correct padding. What I want to see is the end of the section. Are we printing it? We are. Calculated checksum is this. Is this actually the end of our save block? It's probably not even the end of our save block, right? Or our block here. We need to actually go to 11,000 plus 4096. Yeah. So we actually, yeah, okay. I did this yesterday. I need to go to 12,000. So our checksum printed as 11577. Although actually, I don't know if that's telling me this is save block 3. Let me look up the structure again. It's save index 3, which is right. Just before that is the magic number signature. And then, yeah, section ID. Oh wait, no, sorry, checksum then section ID, which is 0. Yeah. So, how did our checksum become 7715? Or 115? That's what I find a bit weird. Like, where's this extra 1 coming from? I mean, clearly it's because we're... I mean, C plus 4, C, D, E, F, yeah. But it's just taking the lower values? I think it just shows how I don't really know how bits and bytes work. Really. Interesting. Okay. Well, let's not complain that this actually works, but let's see if we can enhance anything that we want to do here. So, can we actually check the return value of a void? Maybe it should be some kind of const short number. And we want the number of characters that were successfully encoded. Maybe that's something sensible. So if we encode a character that's not FF, we can increment E count. And then down here, we can return E count, but it's not... Oh. And now it's going to complain that I'm not actually... Return type const short is const qualified at the top level, which may reduce code readability without improving const correctness. So what does Clang Tidy actually want to do? Just call it a short? That's an interesting... If I undo that, I kind of want to read more about that. Return type const. Yeah, let's see. So you are allowed to use const there, but Clang Tidy is also correct in flagging it as ineffective. The related Q&As code readability is reduced because it's a superfluous... Oh. Tempt the client code into mistakenly believing that the return value must be used as a const as well, which is not true. The return value can only be used as an R value. There's no possibility to change. Okay. There's no possibility to change an R value, so const correctness is already given. Okay, yeah. So it is just a kind of useless statement to have. Sure. Okay. So then we can say, once we do our text encode, which, where am I even looking? It's at the top of the file, isn't it? Yeah. Then let's check that E is not 0 and E is not null. Then we'll return 1. Cannot assign binary operator to short and void. Oh, wait. Can we not return null for a short? Is implicitly converted to short. Let's just do 0. Zero is returned. So then we don't actually need that second check. I know it's going to moan that it's not const. Oh, whoops. Well, actually, it may have actually correctly changed our name once again if I name myself Joshua. Input character blank converted to FF. Encoded 6 characters. 0. Yeah, okay. Okay. So maybe we'll now be called Joshua. No, we're just called Josh. But the reason for that is because we need to replace our save file with our dump. Oh yeah, we're called Joshua. Huh. That is amazing. Okay. Alright, that works. That's great. Cool. Yeah, I'm very happy with that. Cool. I think we can probably finish because I've been going for a little bit and I don't want to go for too long. Because it's actually a very sunny day outside, so I need to be getting outside. Probably go on a bike ride. I want to... What do I want to do? Probably maybe try and refactor some of this code to make it a little bit clearer. Maybe we can go through some of these suggestions and warnings. So what's this, for example? That can be const. Okay. That can be null. Oh yeah, I mean, this would be an interesting problem to solve, but I don't know if I don't know if I have time. I'm kind of free this weekend, so I'll probably be working on this a little bit more. But yeah, I would very much like to have a way of dealing at least with this to do, because we kind of want to know where we are within the context of the file itself. But this kind of... I think where it would really come in handy is if we just took the... Like, we can calculate literally everywhere we are in the context of save file. So if we know the address of save file... Fuck it, let's try implementing this. I'm going to stop that timer, which was going to tell me to log out. Yeah, so if we know where we are in the save file, then that's our kind of initial address, right? And then I guess within a save block, we just need to read our save index. Yeah. So I think what we can actually do is have that. So prints the starting address of a given section %s relative to the starting address of the entire save file. And I'm not even sure if we need save block in this case, because all we need to do, we know that the save block is only ever going to be at E000 or 000. So actually we don't need denoted by SF. Yeah, I really don't think we need save block actually, because we can just read the save index of our section, and then yeah. So this is save index is a uint32t. So SF save blocks 0 save index. That is its value. Yeah. and then this one needs to be at 1, 0. And then we can say if so we actually need to check first of all which is bigger, and is our section the latest. I mean, latest, or is it in block A or block B? Is section... Am I actually checking for whether it's the latest, or am I checking for... What is it I'm checking for? So I do need to know which one is later, but I then need to know is my... Okay, yeah. Yeah, so then we get latest index, and then we say is section latest. So is the section the latest one? That is our section save index, does that equal latest index? If so, then it's not. Oh wait, no, then it is, otherwise it's not. Yeah. I mean, actually, this doesn't even need to be a Boolean. We just say... Let's just call this start, and then if save index is... Oh wait, no, hang on, because we need to know if we're in block B or block A. Yeah. And then I guess we can actually check if our section is latest as well. Let's see, section is latest. Section is latest. I don't think that check is right. I mean, maybe it just helps if we do these as separate checks. So we want to know if save A is the latest, and then we want to know is our section the latest. And we can check that by getting latest save the actual value of the larger one. So to check if the section is latest, does that section ID equal latest save index? So then if section is latest and we're looking in actually we should probably check save B is the latest. Then it is E000, otherwise it's 000. 4 zeros, I believe. Where were we? Here? Yeah. Okay. So then to find this relative to our so to find this section relative to our save file, it is the address of our save file plus the address of our section subtracted by the address of our save file. Yeah, because our section is somewhere. It will either be whatever memory address we have plus something. Yeah. So if we subtract the address of our save file, that should be it. Does that need to be... Oh. Yeah, I guess we don't actually need the offset back at this point. The address of our section is adder. I should probably rename these as well to correct camel case. Have I got anything else that's wrong? Probably not. So at the point where we get our section, we want to then print section address. And see if that works. Why doesn't it like save file? Cannot convert save file to parameter type const save file. Oh yeah, because it's not const. This is not const. Oh, it still doesn't like that. To save file pointer. Okay. Oh, that looks correct to me. Searching from offset 11,000 in the file. I don't know why it's playing like clown music when I got it right. Searching from 11,000. Oh wait, no, it always knew it was at 11,000 in the file. Did it print my... It's at the very top. Wait, what do I print? Address of section. Oh. Maybe that would be better. Yes. Yes, okay. Whatever. Let's do it like that. Wonderful. Let's test that again with something else. So let's do... section... Let's pick a random one. Don't want one. I want... Let's do PC buffer E, which is 9. And the address of PC buffer E is 28,000. I mean, there's no date in there, so it will just come up with a load of blanks. Wait, 28000. Oh, hang on, is that not correct? Because this caps out here. Oh. That can't be right then. One FFFF is the last address. Okay. I have a flaw somewhere. Now where could it be? section is latest and save B is latest. Actually, I don't even think we need to do the latest checks, do we? We just take the point. Oh my god, we literally just take the pointer to our section and subtract the starting address of the save file. I don't think we needed all of that. I'm pretty sure we don't need any of that. Like not even the start value, nothing. And yeah, these are redundant now. So rather than adding stuff on, 1A000, that looks more correct. So just before, yeah, okay. Talk about overcomplicating things, man. Oh, how embarrassing. Anyway, okay. Well, we know that works, so... yeah, I guess we can leave it there. So next time, maybe I'll try and do a bit more refactoring, because, I mean, we're having fun editing stuff, but we actually want to be able to kind of select what specifically we want to do and actually make it like kind of a usable program. But this is very cool, the fact that we're now pretty much confidently manipulating data and things are going okay. So that's really good. So yeah, once again, I'll leave it there and we'll see what happens next time. Bye bye.